Hello everyone. In this video, let's solve a differential equation by separation of variables. This is the differential equation that we'll solve in this video. The derivative of y with respect to x is equals to sine of x plus y. Let's get started. In this case, we have this differential equation, but in this way that we have it in this moment, it's impossible to solve it with separation of variables, because we have in the argument of this trigonometric function x plus y, and it is something impossible to separate and solve this differential equation by that method. But we can solve it use a little substitution, this that we have in here. We'll transform x plus y, that it's equals to z. This is the substitution that we can employ in order to solve this differential equation. To use this substitution, let's derivate this equation with respect to x, like this. The derivative of z with respect to x will be equals to the derivative of x with respect to x, that is equals to 1, plus the derivative of y with respect to x, and we'll have this equation. So for this last expression, let's solve for the derivative of y with respect to x. Just this one that is positive pass to the left side with negative sign, like this. And we can replace this information and this information in the original differential equation. So we'll have these terms in here. In the left side of this equation, it's equals to the derivative of y, and in the right side we have the same function sine, but instead you have the argument x plus y, we have the equivalent c. So now we can completely able to separate variables. Just this negative 1 that is in the left side could pass to the right side with positive sign, like this. So let's go to separate variables like this. Just this differential of x that it's divided in this side pass multiplying to the other side, and this expression that will be multiplying in the right side pass to the left side dividing. So we'll have this equation. This equation can be written like this. In this case, just we switch the order for this equation. Instead to write it in this way, it will be written in this other way. So now, in order to solve this differential equation, we can observe first that we separate variables. Now we can integrate both sides in this equation. However, in the right side, it's a really difficult integral, at least in this way that we have now. In order to simplify that expression, let's multiply the denominator by this term. In the denominator, let's multiply by this term, sine of z minus 1. But if we multiply the denominator for this quantity, we need to multiply the numerator but the same quantity. For that reason, we have that expression in the denominator. In this way, we have that sine of z minus 1 could be cancelled with sine of z minus 1, and we have the same expression. So this expression is exactly the same like this. So now let's multiply this expression in the denominator, and we'll get that this product is equal to sine of z, sine square of z, minus 1 to square, but that it's equals to 1. And the denominator it's exactly the same. Now we can factorize a negative sign in the denominator in order to have this expression. If we factorize a negative sign in the denominator, we get 1 minus sine square of z. Why do we do that? Well, in this step we can use this really important trigonometric identity. We know that cosine square of z is equals to 1 minus sine square of z, and we can substitute this trigonometric identity in this differential equation, and we'll have this dx is equals to all this expression. In this part we can divide the denominator to each terms in the numerator. And also we can use this negative sign and multiplying to each term in the denominator. So for that we have 1 minus sine of z. Now we can separate the denominator to each term in the numerator, and we have these two terms. In this point we can use a really useful trigonometric identity. We know that 1 over cos square of z it's equals to secant square of z, and we can rewrite this expression like this. In here we have the identity trigonometric expression like here, and this other term could be rewrite like this. We can rewrite it like 1 over cos of z times sine of z over cos of z. If we do these multiplications, we'll get this term that we have over here. In here we have again that identity that we use in this case. 1 over cos of z it's equals to secant of z, and sine over cosine it's equals to the tangent. So we have these terms now in this differential equation. In this part of this problem, we're perfectly able to integrate each term. So in here we have the integrals for each part of this equation. In the left side we can integrate dx, that will be only x. The integral of sec square of x it's equals to the tangent minus the integral of this last integral, it's secant of z. So we have this expression. And finally we can replace z by the original value. Remember that z it's equals to x plus y. So finally we find that x is equals to tangent of x plus y minus secant of x plus y, and we must remember the integration constant. And in this way we finish this problem. This is the solution for the original differential equation right at the beginning. Thank you very much for watching, and see you next time. Take care.